All right, and we're back in the second video of engine short blocks. I figured I'd have to break it up a little bit because that last one started to get into 30 minutes. It's too easy to get real excited about pistons and rings and cylinders and all that fun stuff. So let's talk a little bit about connecting rods. So we talked about the piston moving up and down inside of the cylinder, right? So there's our piston along with the rings. What about underneath? So we know we've got a crankshaft. That is our set of bicycle pedals. We'll talk about that in a moment. But what is going to connect our piston to the crankshaft is going to be a connecting rod. Some people will just call them rods for short. So our piston is connected to the crankshaft through a connecting rod, which is connected through a wrist pin, which I talked about in the last video through our wrist pin hole there. So if we're looking at the bare rod, it's actually quite a basic anatomy. We have the part that is connected to the piston, which is little, so we call it the little end. That is where our piston pin is going to go through and connect our piston through, right? This is either going to be pressed into the rod or it's going to be held in place in the piston using some sort of clip you can see there. Now, we've got the beam in the center. This beam is going to be potentially shaped a little bit differently depending on what kind of rod you're dealing with. And then down at the bottom where the larger end is, we call the big end. The big end is going to, on some motorcycles, it might just be one piece, smaller engines, but larger engines, it comes in a two-piece. Now this part is how we connect to the crankshaft or our bicycle pedals. So our big end here composed of two pieces. How it's going to connect to the connecting rod is connect to the crankshaft is it is going to be in two pieces, and we're either going to use studs that hold this piece on with nuts, or we're going to straight have bolts that go through and bolt the end cap, we'll call this the end cap, to the entire rod. So if I want to disconnect or dismantle my rotating assembly, which by the way, I keep using the term rotating assembly. Rotating assembly is referring to our pistons, connecting rod, and the crankshaft. So if I want to be able to disconnect everything, I'm going to disconnect it through the big end. Now, with that being said, this can be cast or forged as well. If I'm looking to do high pressure type applications, maybe turbocharging, maybe a really high compression ratio, supercharging, maybe I'm putting nitrous, I'm building this engine to be beefy, I may want forged connecting rods because they're stronger, but that may not necessarily always be needed. It's really depending on application. So those are our connecting rods. Now our crankshaft is going to be, as I keep talking about, as our bicycle pedals, because I feel like for those of you who are unaware of the crankshaft, this is the first sort of class where you've come in contact with that term. It does just that, and its principle is very similar. So I showed you the block where I showed you guys the cylinder end. I'm turning the block upside down now. So we have what we call, so this is the bottom side of our cylinders. And these sort of valleys here are what we call where our main journals sit in the crankshaft, or with the crankshaft in the block. So our bicycle pedals have to be mounted to our block somehow so our pistons don't go flying around everywhere and the crankshaft doesn't go flying around everywhere. So I'm going to go ahead and set in my crankshaft, which my crankshaft looks like this. It's just as if maybe you were an alien and you had a bunch of legs. That would be your bicycle pedals, right? As your engine is spinning, again, this is upside down. We're looking at the bottom side of this. So imagine you're underneath the vehicle and you're looking up underneath the engine. Our crankshaft is going to spin like so, right? You guys see that there are these journals, which by the way, not the type of journal that you write in, but these round shiny pieces on our crankshaft, they're called journals. Your camshaft has journals as well. These journals sit in those main valley areas I was just showing on the block. And these, I'll talk about main caps in a moment, but these main journals, if you look at this one, this one, this one, and this one, as I spin the engine, they stay in place. They're spinning, but they don't move. You see these journals, this one, and if I keep turning it, this one and this one, those are your rod journals. So if I was to pretend that our piston was facing the other direction, my connecting rod would connect to those rod journals, and as my crankshaft spins, this is not the correct rod for it, I've got my piston moving up and down, up and down. So when my piston goes down on its power stroke, it's shoving down the crankshaft. And as it comes back up, that's my exhaust stroke. So we've got, let's start our 4-stroke cycle. Again, we're pretending that this piston is in the cylinder and that this block is not upside down. But my piston, you can watch my rod journals here, moves down on my intake stroke. It's going to continue to move up on my compression stroke, then get shoved down by the power stroke, and then back up on our exhaust stroke, so on and so forth. And I've got another piston on this journal. I've got another, connecting rod, another connecting rod and piston on that journal. All of my rod journals are connected to a connecting rod. So our crankshaft's job is to turn the up and down motion of my piston into a rotary motion. So if we look at, this is the front part of my crank, but if I was to turn this crank over here, this is the back side of my crank. As this crankshaft is getting shoved down in a particular order, first on this one, then maybe on this one, and then on this one. So as our crankshaft is getting spun by each power stroke on each cylinder, we are creating a turning or twisting motion back here, a torque, if you will. So our crankshaft's job, if you were to say in one sentence, what's the job of the crankshaft? It's to turn a reciprocating motion into a rotary motion. And the rotary motion that comes off the back side of the crank is going to be connected to our transmission in some way, shape, or form. Now the transmission is going to have gears in it to change the gear ratio and stuff we'll get into when we get into transmissions in this class. And then it's going to transfer to drive axles, then to our wheels. So this rotary motion is what we're really trying to attempt. That's the job of the crankshaft. Again, like many of the other rotating assembly parts, it can be cast, it can be forged, or it can be billet. So what is billet? We know what cast and forge is. Billet is where I've got a hunk of metal and I pretty much CNC cut out my part. So that means I take a block of metal and I cut out a crankshaft from that block of metal. That would be billet. The main benefit of a billet crank is that it's custom in any way you want. So let's say you want to change something. Your crankshaft is what controls directly your stroke. So the amount of distance that this rod journal is from this main journal is what determines your stroke. The further out this rod journal is, the longer your stroke is. So let's say I want a custom stroke that nobody makes a crank for. I would order a billet crank that can be a stroke of whatever I want can be cut. And that would be the main benefit of your billet. So I already talked about our main journals. That's the area of the crank that spins in the block. The rod journals are the area of the crank that connects to the connecting rod, kind of like your pedals on your bicycle crank. The pedals on your bicycle crank, that would be your connecting rod journals, if you will. And then the center portion of the crank on your bicycle would be your main journal. So as we go through and get a closer look at our crankshaft, I'm going to set this up so you guys can sort of see here. You guys see how there are holes in our connecting rod journals. Those holes are for oiling. So what will happen is as my crankshaft is fed oil, it is going to transfer through little little passageways through my crank and oil inside of my connecting rods, because there's going to be a lot of friction, right? Even though it's spinning, it is touching each other, and so there's going to be a lot of friction. So we need to be able to oil our connecting rods through that way. This bottom picture here is showing you the valleys or the passageways in which oil will sort of come through and out. Also, you'll notice that if we look at our crankshaft, it doesn't just have main journals that go down the center and our rod journals that are offset. We also have these sort of big hunks of metal hanging off of the ends on some of these areas. Those big hunks of metal are called counterweights. So our crank can be balanced and produce less vibration as it's spinning. Because we're talking lots of revolutions per minute. When you're talking RPM, that's revolutions per minute. It just sitting at a red light. If your car is idling at 500 RPMs, that means this crankshaft is turning 500 times per minute. Now, that's not even talking about red line. Let's say on something like an import, you might be redlining, 6,000-7,000 RPM. That's a lot of rotations of the crank. And so if we're not balanced in any way, we're going to get lots of vibration. And it could either damage the engine or it's going to make it uncomfortable for the passenger inside driving the vehicle. So that's what the counterweights are going to be for. You can see our mains in the center here that they're spinning, but they're not moving out of place. They need to be held in so our crankshaft doesn't go flying out the block, right, or out the bottom of the block. So we've got these caps that are sort of this half circle shape that are meant to sit on top of those main journals. And that's going to hold, let me hold it in place. It's going to hold our crank in. It's going to bolt our crank in. Now there's a number of ways we can do this. So on this one, I would have a main cap here. I would have a main cap here, a main cap here, a main cap here, and a main cap here. On some engines, you're going to have separate main caps. And you can see on this main cap, you see how there's 4 holes? That's a 4-bolt main. And obviously, the more bolts holding a main cap in place, the stronger it is, and the more pressure we can sort of put on that engine and those main caps. So it's going to have a higher capability without sort of the crank wanting to fly out of the engine. So we've got 2-bolt mains where it's just 1 and 1. I've got 4-bolt mains where I've got 2 on each side. I've got 6-bolt mains where I've got 3 bolts on each side, or where I've got 2 bolts on top on one side and then 1 bolt through the side like that. Again, the more ways we can hold that crankshaft in, the more we can throw at that engine. With that being said, some manufacturers said, hey, let's stop doing main caps and let's just do one whole big piece that sits on the crank and bolts it into the block. So we'll call those, there's actually a number of names depending on the design. It's either going to be called a girdle or it's going to be called a lower block assembly. So I gave you guys a couple of pictures in your Canvas presentation. So here would be an example of our main caps. They're individual main caps here, same with over here. We've got what looks like 4-bolt mains. It might have a bolt in the side. In that case, it'd be sort of a 6-bolt. Up here, I've got a picture of what would be considered a girdle. There's going to be, I don't have a picture up here, there's going to be certain engines. BMW has a couple of different designs. So do some other engine manufacturers, that it's actually a whole, like almost a lower block assembly that sits on top to sort of strengthen the lower portion of the block. Toyota did a girdle for a lot of their engines. Even Honda on the single cam engines did a girdle on the D series. So, but then on the B series, they went to main cap. So some engines have girdles or lower block assemblies, some have main caps. It really depends, but that's how we hold the crankshaft in. Now, with our rods and our main caps, we've got our crankshaft spinning in between those. The problem is I've got metal on metal that is spinning within each other. That's friction. we don't want that to wear out and then have to replace all of the connecting rods, completely replace your engine block. So what we do is we put a wearable component in between them, kind of like brake pads, right? If I didn't have brake pads, I would have to replace a caliper and a rotor every single time I needed brakes, and it would get very expensive. So we're going to have cheaper wearable components inside the engine. Inside of our engines, on our main journals and our rod journals, we are going to use bearings. Now, when you think of a bearing, you're thinking of ball bearings or thinking of like bearings on a skateboard, right? It serves the same purpose. It's to remove friction or reduce friction. However, these type of bearings are a different type of bearing. You see there's no sort of rollers or balls here. Instead, it's sort of a compound of softer metals that is going to go in between our rotating components, and it's going to reduce friction. Now, there's a couple of things to mention. So it acts as a cushion between moving parts, like I just said, but it's also a soft metal that's meant to absorb dirt. So if any sort of tiny, let's say specks of whatever contaminant gets in here, it's meant to act as sort of this cushion that it gets embedded into, and it sort of holds it in so it doesn't damage the crankshaft itself. So it's also meant to sort of absorb contaminants and take them away from our rotating assembly. And it acts as a wearing surface. So when I need to rebuild my engine, I just replace my bearings. I don't have to replace the entire crankshaft or the entire connecting rod or the entire block. So these bearings can come in a couple of different designs. We can have full round bearings, which I've got a picture here. I don't have one on hand where it's a complete circle. Your old overhead valve style camshafts that go inside the block, they use the full round bearings. But your main bearings and your rod bearings come in the split type design. So I've got a bottom half and I've got a top half. Your rod bearings are generally going to be smaller, while your main bearings are generally going to be a little bit larger. One other thing to note is that a lot of times your bearings may have a hole in them. Make sure that the hole lines up with the hole either on the block or possibly even the rod, because these holes are for oiling. Now, if there is no holes there and your bearing has a hole, it's not that big of a deal, but if there's a hole in the rod or a hole in the block, you need to make sure that you're using that hole to line it up, because if you don't line it up, you're going to starve the bearing of oil and lubrication.